All right, let's begin. And one of the things that we're going to be doing today is discussing inheritance and composition. This will also get you ready for assessment towards the end of the quarter. So we are going to talk about is a versus has a and data structure relationships, and that means relationships with objects and how objects can relate. And there's actually two different ways that objects can relate to each other. And by the way, the reason why we're doing this and needing to learn about this is because, we're learning about objects, but why are objects so important? And that's the reason. The ability for something to be contained in a box, and you have the ability to protect the data in that box that we call an object. But not only that, but have functions that can act upon that data in your box that you call that object. That changed everything. That changed the world because software development was so slow. You used to have to wait a year for your software to get done for any new hardware. But after object-oriented programming came out, basically the software is already written for the hardware. Yeah, it's kind of interesting thing here. But let's talk about that is a versus has a relationship first, and kind of how that relates with objects and when they or how you relate objects. So you have two ways. You have inheritance. So inheritance is the is a. So is a. And when I'm saying this is a has a, that's how you know to use inheritance versus composition. Composition is another way that we relate objects. Because what's better than one object that doesn't have another object inside of it? Or, hey, how about if that object had another object inside of it? Composition is a has a. And this is a very important one because it comes up a lot with the member, the dot operator that you use a lot to access functions or objects that are inside of objects that you're using. So all this stuff you're actually using right now without really kind of knowing. So we're going to be adding, or we're going to talk about this and how they relate with a code example here soon. But let's just kind of look at what kind of objects and give some examples. So when you're dealing with inheritance, the goal is that you have a base class. Your base class is generic, always generic, and that is because you want to be able to have multiple composition. So when you have a base class, and let's call it, let's say that we're going to have a base class, and I'm talking inheritance now. It's going to be something that we could say would be like an animal. Let's say we're going to have an animal class. And inside that animal class, we'll have things like data for the animal, like eye color or whatnot. But this is generic. We could declare and create animals, but sometimes you want to create a base class with generic properties. That way you can then inherit from that base class into like a cow. And here is the idea, is that the cow class inherits from the animal because a cow is an animal. That's the is a. That's where inheritance is used. And you would like, and this is cool because over here we can have a tiger or something like that. You know, if I can actually get this silly goof thing to work. So we can have a tiger. Because what we can do is we can take all that code that was written from the animal and use it for the tiger. Therefore, we don't have to rewrite it. And the same thing with the cow. So that's why when you're dealing with inheritance, you always have a base class that's generic, because by the time you're done with your inheritance scheme, you have a whole technology. In fact, this is the way Java is built, and C#.net. They're all super object-oriented programs, to where even main is an object itself. So the program itself is an object. So here's where then the next thing goes up your inheritance chain is we can come off of this cow, and we can have like red cow or a super cow object, because a red cow is a cow and a cow is an animal. So I can have a red spotted cow can come off of red spotted cow, or you can do red spotted cow here. That would probably be more red spotted cow, or your super cow, or whatever. I wonder if there's a super cow cartoon out there. Who knows? But anyways, this is all an inheritance hierarchy that is based on inheritance and the is a relationship. So whenever you're doing inheritance, it must be is a, because you want to inherit in a manner where you go from generic at the lowest base class to more specific as you go up the chain of your inheritance hierarchy. And before you know it, you're up here way up high in some kind of in an object that like a text box object in Java or C#, and it has all the characteristics of what a text box object needs, all the way down to the very variable that holds the text. So you start with this base class being generic, but it's also something, it has the characteristics needed at that level for what the object represents, but you need to be more specific as you go up the hierarchy chain. And that's the idea of the is a relationship. Now the has a relationship is different in that, yes, a cow is an animal, but doesn't an animal, a cow and whatnot, don't they have things? So with this animal-based class, what we could have is an animal has stuff. So we can have a data item that would be, we can create another object over here, and this one won't be in an inheritance hierarchy. We'll call this a leg object. And an animal, we know that most animals have two legs. So with the has a, instead of inheriting, we put the leg right in here. And so we could do like a var a equals leg or whatever. Var a leg, I think is, or let a equal a leg. Okay, so now this a is inside of the animal class, and so now an animal has a leg. So you actually declare the variable inside of the object to make that composition work. And your book does not do a good job at this at all. It doesn't talk about composition like it should. It's more of an implicit concept. But when you get into one of your assessments, you're going to have to show that you know about composition. So composition is where you have a, that means inside the animal has a leg. Inheritance is where you are a, or is a, the cow is an animal. What's nice is once you create the legs in here, guess what the cow gets? The cow gets the animal's legs. So that's kind of cool, because you can build up the animal and everything an animal needs and write all this code for an animal and then inherit from tiger and then have it all ready to go. I mean, just add in the stuff that makes it a tiger and then it's all ready to go. It's a tiger. Or the same thing with the cow. So that's the idea of the rapid application development, is that with the inheritance and or how it changed everything when it comes to software development, is to be able to protect the data inside of the object, and not only that, but have functions that act upon the object. That means behaviors that you can act upon the data inside the object itself. And having that all self-contained in its own little box, its own little name, variable, scope, everything, changed software development. In fact, it was what caused the dot-com bubble back in the late 90s, early 2000s, was this bit of advancement in computer science. So let's put it to some use. Let's give you some actual code examples. I'm gonna go steal some code, and then we're gonna modify it, and I'm probably gonna goof up as we go. I'll probably start writing C# or Java or JavaScript or C++ or C or what are the other ones? PHP, yeah, that one too. Yeah, I'll start writing other language of code and have to probably pause a few times. You know what? Let's go with the first pause. I'm going to go ahead and get some code ready to go for you. Be right back. Okay, I'm gonna take one of your examples here from the course, and we're going to modify this contact object from your book's code. I believe it's like chapter something or another. But that's okay, because we're going to change it all anyways. I think it's in your chapter 10 data files called contact.py. I'm just going to use it as a template. That's all. Car would work too. Just so I don't start writing other code. So I know I'm working in Python. So let's go with an example for this demonstration. I'm going to go with the study guide for your final. And in that study guide, you have an example of a data structure that I want you to build that has relationships with other objects. And that is when we consider that we can have three objects: building, house, and house address. We want to make sure that house inherits from building and be composed of a house address object. And that is because, and this is the way you're going to do it on your test, just do is a, has a, and then think about, okay, what is a? And these three objects: is a house address a house? Is a house address? Well, when you're thinking, you might think, well, yeah, a house address and a house are synonymously the same thing, but more or less, we need to think it through with the is a, has a words. Because it just does not sound right that a house is a house address, but a house has an address, and there's where the answer lies, because isn't that address inside or on the house part of it, a component of the house? And that's where composition comes in. Component of the house. That means the house is built up of those components. So when we think about the animal class, in composition, a leg object is a component of the animal. And inside the leg object, we can have a toe object. That would be the toes of the animal. So it's what the animal or the object is composed of, and that's why we say has a. And in fact, you've been working with composition this whole time. Every time you put a variable in your object and declare it, that's composition. But mostly you've been doing it with primitive data types like integers, doubles, floats, strings, regular stuff. Not other built data types, not other structures that you've designed and built yourself. So when we think about is a house is a building. Okay, so, and then when we think about has a, of the three, all three need to be related. If a house is a building and a house has an address, then we immediately know that of those three items, the one that has the most connectedness to it is the house object. So that's going to be our base class. Oh wait, no, because base class should be building, because isn't building more generic than house? Yes, yes. So then we can do a little diagram that might help us do the design and get it straight in our head that we have a house that is a building and a house that has an address. And you could do it with little boxes or whatnot. You know, it's however you want. Once you get it, you know, you understand how the code comes together, you probably won't use boxes anymore. But I can think about it as the building being the bottom. So that would be the building. And that's the base class because it's more generic than the house. And the house is going to be the derived class. Okay, and then inside the house, we're going to put an address. That one is not inheritance. The house has an address. Here's the address object. We're probably going to call it something. We'll call it, yeah, I'll probably be stupid and call it the address. Yeah, no, that's not good naming conventions. Probably, we'll just call it address. Yeah. Okay, so this is kind of the hierarchy. This is my drawing. I know that building is probably the base class of house, and house has address inside of it. So what I want is I'm probably going to want to design building first because everything springs from building. And then the house, and then inside the house will have an address. So let's go ahead and go in there and modify our code. And I'm going to cheat a little bit today. I'm going to put this all in one PI file. You guys should be putting it in separate PI files, by the way. But I want to specify something particular, and this is the reason why I'm putting in the same PI file, is if you are inheriting from building into a house object, then you got to declare the building first, because before the house can exist, the building has to exist. The address you can have off to the side. It doesn't matter because it's not relying on inheritance. It's just going to be inside of the house. So that one you could do at any time. But let's start with the building, and then we'll go from there. Okay, so this is going to be our base class, building. And we're going to have our init, and I'm going to be fairly simple with this. I'm only going to be putting one variable in. Now, your examples would probably have more, but what we'll do is we'll do a size in square feet, and that's enough. I don't want to take up too much of your time doing stupid things. Okay, so we'll just throw in size here as what we're going to send the building's constructor when it's implemented. And we're going to be doing something special coming up with this init function, especially when we use inheritance. Okay, now the set name, set phone, set email, get name, get phone, get email. Let's get rid of all these. And let's put an str method in there so that we don't have to do any separate prints of the get. So we can just print our object and see that it works fairly easy. Now you guys are going to have more than this for your examples when you go to actually do this particular task in your upcoming assessment. So here we go. We've got building. This is going to be set size. And we assign, oh, no, that's get size. Oh, excuse me. That's the init function. So set size, okay, right here, size. Oh. Okay. And get size. This is just going to return size. Pretty simple for now. Just one. You're going to add more. And let's get rid of these things because we're not really using the comments. Okay. Okay, here's the string method. Well, we're only using size, so we're good here. We just need to change that to size. And then we'll put a little designator building size. Okay. So that's our base class building. Very simple. I don't want it to be any more difficult than that. Okay. So then that allows us to be able to declare our house. Now you would do this in another file, and you would import building into your house py file. What I'm going to do is I'm going to throw it right below. We can't put it above because if we try to inherit from building, building isn't defined until here. So if we're trying to use building and we were building this house.py, we would have to include the building.py into our source code. But I'm going to do a little trick, and you guys must do them in separate files. But that's just for also having this discussion. I'm going to put it down here, and it's going to work fine because we already have building defined. So I believe, if I remember right, I can't remember, but I think you put the colon here to inherit, and you say building. And now we are inheriting from house. So now a house has everything the building has, including size. And when we instantiate a house, we can access those details. So what we can do now is we need now a main function, and I'm going to just call main here, and I'm going to throw in a quick main. And then what we're going to do is we're going to do a house instantiation. Let h equal house. Okay. So let's see if this will actually compile. I'll save as to. Okay. Let's see if it will run. I may need to put it on pause. And oh, I'm using Visual Studio Code today, by the way. Yeah, I like it. It's all right, but it does do these stupid things. And then also I hate the you have to always hit that insert key. Drives me and stuff. Okay, it looks like I'm doing main wrong. Yeah, I'm not gonna fumble around. I'm gonna put it on pause and get it fixed, and then we'll come back. Oh, duh. Oh wait, no, that's not it. Okay. Yeah, pause, and I'll fix it up. Okay, so I believe I have it. I was just doing main wrong, that's all. So it looks like, so right here on line 20 is where I'm doing the instantiation of the house. You notice here I'm sending in 1500 into the init function as the size. So this is me instantiating the house in main. And what we can see is, since the house inherits from building, it's going to have all the traits that a building has, including these functions and the data inside, such as the size variable. Looks like I found a little error there. Fix that. Okay. Now, when I use H, I should be able to see that it has those characteristics in the member access operator. And you see here that, sure enough, I do an H dot, and I got set size is there. It looks like it has some other attributes. Set size. I'm wondering if this is entirely a house. Let's see. Oh, it should be just size. Should be just, oh, the set size is right there. Set size. Okay, and then the get size is available to us. We should have h dot get size. Okay, but we shouldn't be able to have access to size because we're protecting that with our accessors. You don't want, nope, it's not there. Well, it's there, but you don't have access to. Okay, so that is creating a house and passing in the 1,500 square feet for the size of the house. That's our building, but what does a house have? So a house is going to have some characteristics, and not only that, but since a house is a building, don't we need to interact with the building part of the house? Meaning we need to make sure when we create a house, we can have the init function run properly. So then what you do is we're going to go ahead and complete our house here by adding the init function and the string and the get. So we're gonna add stuff to the house to fill it up. I think yeah, Control C has a whole different meaning in Visual Studio Code. I hate that I have to. I might even end up going back to Spider after a little bit while. Okay, so let's flesh out this house object. Okay, we're gonna have an init, but instead of size, we're gonna have size. We need size because we gotta pass that down to the building init function. But a house is also going to have something more than a building that's specific to a house only. And what do houses have that buildings don't? Well, what makes a house more specific than a building? Oh, it has bedrooms. Yes, so we'll do here bedrooms. This will be just the bedroom count. We'll call it n bedrooms. Number of bedrooms, n bedrooms. That'll be simple. Okay. So that's going to be specific to the house. But this self_size, that's going to be happening inside the init function that we have in the, we use what we call the member init operator of an init function. So we're going to actually pass that down and do something with this here shortly. We're going to have to look at the member init list is what they call it in other languages. Let me make sure I'm recorded real quick because I OCD. Okay, thank you. So the member init list will allow us to call the init function of the house, or excuse me, call the init function of the building from the init function of the house. Since we're creating a house down here, we also need the init function of the building to work. So we're going to have the init function of the house work, but we also need to pass in the size so that we can go in and have this code, or we can go to the part of the house that is a building and set that value. So what we'll have here is we're going to go ahead and do the number of bedrooms. Equal to n bedrooms, and then this is going to be set n bedrooms, and again you're going to have a few more than this. I think you need to have like 2 of them, and we'll just take this bedrooms and then n bedrooms. I gotta fix that other one. And then this is going to be get n bedrooms. and return n bedrooms. Okay, and this one is going to be return house number of bedrooms. It's going to be n bedrooms. Okay. All right. So that is having some problems somewhere. I think it's right there. Yeah, that's what it was. For some reason, well, that doesn't make any sense. The returns should be in more, shouldn't they? Okay, I'm gonna pause this, and I'm gonna get the house all built up and looking good. It looks like I've got some simple issues with just tab operators, I think. I'm gonna give it a quick roll real quick, but it looks like it's something to do here. Oh, I'm doing this wrong. I know I'm doing that wrong. I'm doing that with different software, so I'm gonna go look that up, and then we'll come back to it. Yep, sure enough, that was C++ code. Okay, so let me go back to that example that we're doing, and let's fix it up. It looks like this is the way we do our inheritance. And then I got one more lookup that we're going to do. So it looks like the syntax is, oh, that's it. Okay. So you got to put what you're inheriting from in parentheses, and then you do the colon. Okay. Okay, we got our house, and we are recording again. We have our main, and we're able to instantiate our house. The only thing that, oh, this is not liking me. No, it should be, yeah, this is in bedrooms. No, it's fine. We'll come back to that a little bit. Okay, member init list. Because we need to enable the constructor of the building to run from the constructor of the house. Let's see how Python deals with that. Python member init list. I think it looks like, this is an example that I think maybe you got to make it happen. I bet you there is. There probably is not a member init list. You know what? Yeah, there is. I've actually even written the documentation. We're back to another pause, guys. I'll be right back. So what I'm trying to do is I'm trying to call the base class constructor. I'm trying to create the house and call the building's constructor from the house. So what I'm doing is I'm searching for Python inheritance call base class constructor. How to correctly call base class constructors. The super method. The super method, of course it would. Be the super method. Okay, let's see what we got here. Some examples. Okay, I think maybe something like that. Oh yeah, calling a super from a super. Yep, you can do that. That's because every base class can also be the derived class. Let's see if we can't get this in there to work. So I'm in the init function of the house, and I want the init function of the building to run. So I've got to actually pass into the constructor of the house the data for the what the house is expecting, which is the size of the house, and the data for what the house needs. So then I got to pass that size down into the the derive or the base class's init function. And that I'm going to do because we pass in size here. So I'm going to use the super, which directly calls on to the part of the house that is a building. So this is like saying building run init. And it looks like once I get it working, we're going to come back off pause. Okay, so it looks like I have got that super code working. So it looks like the syntax has gotten a little bit better. What I'm doing from the house init function is calling the super's init function and sending it size. So that means what that does is when you say super here, you're saying go to the part of the house that is a building. Because the super, the base class is a building. And then you're specifically calling the init function, and then you're passing in size. And that's going to invoke the init function for the building that assigns the size. And that's the way you want to do things when you're using an inheritance hierarchy. Is you want to invoke each of your base classes init functions from the derived function init function. So notice how I'm passing in the variable to pass down into the building. So what we can do now is we can probably do a quick breakpoint, and let's start debugging. And then what I'm going to do is I'm going to do a step into here. And what's going to end up happening is it should, if they built this one right. Am I using? Oh, I'm building. Let's see how good they did this one. Okay, good. It goes into the house's init function. So I did a step into on this line right here, which is when I'm actually instantiating the house. And what the step into does, other than the step over, is it goes into the code behind the scenes of line 32. And then we're able to look at this one, and this line I want to see what happens. I want to make sure that it invokes the init function of the building. So I'm going to do another step into. Oh yeah, it worked. There it is. So it went into the init function of the building, and did size get passed? Yes, it did. Oh, life is beautiful. Okay, this is working properly. So now, when we're done initializing the base classes information, now we go to initializing the other part of the house, such as the number of bedrooms and stuff. And then we're done and we're ready to use our object. Cool. Okay, so we got the inheritance hierarchy good. That's great. That's only part of the issue now. Because we've got not just inheritance, but composition to deal with. So that means that for a house, we also need to be able to have another data type that the house has, and it's going to be the house address. You can put this between building, but remember, this should be in its own file, and you should be importing this. If you don't do that, you're going to be losing points. Okay, so class. This is the one that is inside of the house. This is going to be house address. And it's going to have pretty much everything that the other ones have. Yeah, I sometimes I hate this program because it just does not play nice, but well, it plays nicer than some of them. Okay. Because it's always going between insert and not, and it's driving me insane. Okay, so a house address self, well, what is address? It's going to be, let's call it the address. And then this will just be address. And yeah, and let's make this easier. Let's just, I just double click on it and then do paste. Oh, you stupid thing cannot handle. Can you seriously? This is Visual Studio Code. Okay, Spider. I'm using Spider next time because this is driving me up the wall. Control V is not working. Paste is not working the way it should, unless you have I think insert on, and you should be able to double click that and just say Control V, but evidently not because it just messed everything up. Okay, let's do it the hard way. I'm fine with that. Okay, let's just go ahead and go in there and take care of these things, and then we're gonna do the demo. We're gonna actually get this working all in one instantiation and printing. So this is going to be set size. This is going to be set address. This is going to be get address. And then for the str function, we're just going to say address. Okay, get address, set address, init. So house address. Okay, so you see we've got the definition. We're not done yet. The address is great, but we need to use this. And how do we put this object inside of where we're going to use it properly? Looks like I got a tab off there. There we go. That should be playing nice now. Looks like something's not right. Doesn't like that for some reason. Oh, it might be something stupid. We've declared the house address, but we're not using it in building or house. So those three objects are not related yet. We only have two related. We only have house that inherits from building. But with the address, this is composition. So what we now have is then a variable that goes inside of the house. Because a house has an address. But wait a minute. Don't most buildings have an address? No, my shed doesn't have an address. So no, that wouldn't work. So a house has an address. So what we can do is we can create that variable here in the as part of the data inside, and here's where the composition happens. This house address is going to be equal to the address class. The house address, and it looks like, what are we sending into the constructor? The house address we're sending ourself and our out. Oh, I'm forgetting this. I'm forgetting the colon. That's why it's being stinky. Okay. Am I still recording? OCD. Yep, good. Okay. We are now creating the house address on line 33 for the house. So I say I want a variable called h address, and then I'm going to assign it equal to a house.